Hello everyone and welcome back to the video of chapter 4, in this case 4.3, which we're going to work with square roots again, and this time we're going to start simplifying them. This paragraph is, I think, the most important one of this chapter, and it will introduce you to a lot of rules when working with square roots. And I know from personal experience beginning this year that you find this sometimes quite difficult. So know to practice this enough, write down the rules and know the difference between the rules, okay? That being said, let's start with the first example, Introduction to Theory A. I'm giving a square with the area already given and also the sides already given, square root 10 and square root 10. We know the area of a square is length times width, right? So here the area of the square must be square root 10 times square root 10. And that is the same as saying, well, the area is square root 10 squared, because a square is doing something times itself. And we know that the result of that must be 10. So apparently, if I take the square of a square root, the square and the square root cancel each other out. They're each other's opposites, the inverse. If I do the one and the other as well, they cancel each other out. It's the same as saying plus 3 minus 3, or times 3 divided by 3. Square root and square cancel each other out. That's the first rule that you have to know. The square of a square root gives me back my original number. So in rather, you can say abstract form, the mathematical notation is the square root of a squared equals a. Here, for examples, the square root of 4 squared is 4. The root of 10 squared is 10. The root of 109 squared is 109. And the root of 14.5 squared is 14.5. It always just gives you back the original number. Let's see how I can apply this new theory in combination with a theory from chapter 1, which was about the power of products. We're not going to work with letters in all exercises. Remember that letters can also sometimes just be numbers, or a combination of a number and a square root of a number. For the first exercise here, calculate, we don't need this. We do need this new rule. The square root 3 squared gives me back just a regular 3. But here, minus 4 square root 3 squared. Remember, there's actually a multiplication dot in here. So I have minus 4 times square root 3 squared. And this rule that we discussed in the first chapter says I have to now take the power of both those things inside the brackets. In practice, that means I have to square the minus 4 and I have to square the square root 3. Minus 4 squared times, because there's a times here as well, the square root of 3 squared. Minus 4 times minus 4 is 16. And this is just regular 3, right? It's the same exercise as here. And 16 times 3 is 48. Remember, minus 4 times minus 4 gives me back a positive number again. If the minus 4 is outside of the brackets, that means it's not going to be squared. So just copy it and just take a look at what's after that. In this case, square root 3 squared, which is just 3. So here, yeah, you can write this down if you want to, right? But this really is an intermediate step that you don't have to write down. I would immediately write down minus 4 times 3 equals minus 12, of course. So only square, that's what's inside of your brackets in this case. If we combine those two kind of exercises right here, just copy the square root 4, we can calculate that later, and square everything that's inside of the brackets here. So square root 4 times 3 squared times root 2 squared. And now start calculating. Square root 4 is 2, because 2 times 2 is 4. 3 squared is 9, 3 times 3. And root 2 squared, remember, it's just my original number. So here it states 2 times 9 times 2 equals 36. Okay, take a good look at those 4 examples and try to do your homework exercises after that as well. Good luck.